Check out these two parts. Here's part one. You can see faceted surfaces and ugly polygon shapes all over the part. And here's part two. It's the exact same part, but with the remarkably smooth surfaces and finish that you'd expect off of a Markforged 3D printer. They're both derived from the exact same design. So why do they look so different? I'll give you a hint. It's probably not your printer's fault. I'm Austin, and this is Reinforced. Today, I'll show you exactly how to export a high-quality STL with the right resolution to make sure that your 3D printed parts always have the best dimensional accuracy and surface finish without slowing down the slicing process. So let's talk about STL files. If you've ever run a 3D printer, you've almost certainly encountered them before. STLs have become the industry standard file type that slicing programs use to prepare parts for additive manufacturing. They describe a three-dimensional triangulated mesh surface, approximating the smooth, continuous surfaces of a 3D model that you might create in CAD. And as you might have guessed by now, the settings with which you convert the CAD design into an STL can heavily impact the resulting mesh. You may be asking yourself, why would the settings I use to make an STL impact print quality so heavily? Well, the STL mesh directly informs a slicing program on how to make the printer's nozzle move around. STL export settings feature many adjustments that allow you to either closely match the geometry at the cost of increased file size, or to reduce file size by sacrificing accuracy. Many engineering parts have at least some curved surfaces designed into them, which are especially subject to visual defects when they get approximated by a relatively low number of triangles. In short, if you don't nail your STL export settings, your parts could wind up looking something like this. Let's jump into Fusion and look at an example. So we're done designing our part in Fusion 360. Let's export it into an STL. Once you have a finished part in Fusion, you can come right up to right-click on the component and choose Save as Mesh. This is going to pop up the Save as Mesh window where we get all of our options to choose from. One of the first things to check out when we come to this Save as Mesh menu is going to be the unit type. It's really important to make sure that the units that you select here match the units that your slicing program expects to see. For example, if we exported this in inches, but our slicer expected a part in millimeters, your part's going to import into your slicing program at a different size than you expect. So we're going to choose millimeters since that's what we'll be slicing it with. Checking the Preview Mesh button will let us see the triangulation of the surface of the part so that as we adjust settings, we can see how they manipulate the output. You'll notice that under Refinement, you get a couple of different preset options that are going to modify how dense the mesh looks. If I choose Low, you see a very low resolution mesh. Medium and High will accordingly increase the density of those triangles. But if we want to get really customized with it, you can choose this drop down next to Refinement options and get a lot more control. Walking through these parameters step by step, the first refinement option is surface deviation. And this is going to control the maximum allowable distance between the actual surface of your CAD part and the resulting mesh. You'll see that by dragging it downwards, we get denser and denser mesh surfaces, which means that that mesh surface is going to more closely map to the actual surface of our CAD part. We recommend that you keep the surface deviation value in or around the ballpark of 0.1 millimeters. So I'm going to punch that in right here. Next, we've got normal deviation. Normal deviation, which is also sometimes referred to as angular tolerance or angular deviation, controls the maximum allowable angle between two normal vectors of neighboring triangles in the mesh. As we crank normal deviation up, the mesh is going to get lower and lower resolution, and as we lower the normal deviation, we're going to see a higher and higher resolution mesh. We recommend that you try to keep this at about 10 degrees or less. Keeping this value at 10 degrees or less, which is what I'll punch in right now, is going to ensure that we've got a good balance between a high enough resolution STL for accurate 3D printing and a small enough file size to not be cumbersome for our slicing program. Maximum edge length is a parameter that may be relevant if you're doing some sort of finite element analysis or simulation with your parts, but if all you're doing is 3D printing your part, cranking it all the way up to its maximum is definitely not going to degrade your part quality. You'll notice that regardless which refinement preset you choose to use, the maximum edge length and aspect ratio are always set at these default values, and it's fine to leave those as is. The last thing to check before we export our STL is the format. There are a couple different versions of STLs that you can choose from, ASCII and binary. ASCII STLs contain human-readable information that's not actually necessary for 3D printing your part. So choosing binary can result in file size reductions that can be beneficial for much larger parts. We recommend choosing binary just to reduce your file size, as there's not really any degradation in quality. And that's it. It's that simple to make sure that you get a high quality part every time. All right, so let's recap. Make sure your surface deviation is no higher than 0.1 millimeters. And we suggest that you keep your normal deviation no higher than 10 degrees. If the file size is significantly larger than about 20 megabytes, ensure that you've exported in binary STL format instead of ASCII to minimize the file size without sacrificing quality. If your file size is still too large, gradually increase your surface and normal deviation until it meets your criteria. We now know that a higher resolution STL mesh will produce a smoother, more accurate model, but don't feel like you need to crank up the resolution all the way. After a certain point, the resolution will just exceed the precision of your printer and result in longer processing times for your slicer. Lastly, if you're not a Fusion user, our blog post features recommendations that translate these settings to SolidWorks and other CAD programs, so be sure to check that out. And just like that, you have a small, high-resolution STL file to print amazing-looking parts. I hope you found this video helpful. Do you have any questions? Do you have a topic that you'd like to see us cover that you've been dying to learn more about? If so, make sure to leave a comment. If you want to see more 3D printing tips and tricks, subscribe for monthly videos on 3D printing best practices. Thanks for watching, and happy printing.